have been to a bookstore to find the textbook to enhance my understanding of Thevenin equivalent and equivalence of this circuit. If there's voltage source and RS, V0 and RS, or I0 in parallel with RS, if R0RS equals V0, these circuits are equivalent. And also the textbook says I had been reading the textbook in just for about 3 or 4 minutes at the store, and I finally didn't buy it. But or capital RS equal capital RS, and and the current flowing through the load IL equal VO divided by RS plus RL from this Thevenin equivalent. Thevenin equivalent says this, and this current is this current, and this current is not looping through, and I0, I1, and this is I0. And so check again if that's okay. And if these are okay, we use Thevenin equivalence to calculate like circuit like this, and maybe this and this, and this, Z1, Z2, Z sub 3, Z sub 4, V1, and this is V out. To derive the Thevenin equivalence, we need Z out looking into here, node 1 and between node and 2 is to get ZO, Z sub 0, we need to short the voltage source and open the current source, and which says if Z1, Z2 in parallel, and this is shorted in the bottom, on the bottom Z3, Z2, Z4, Z sub 4, is in parallel. D2, Z2, Z4, D1, Z1, Z3, Z2, Z4. So, and this is this parallel and series combination. The distance impedance is Z O. So Z0 equals Z1 in parallel Z3 in series with Z2 in parallel Z4. And with this, we need one more parameter, which is open voltage between 1 and 2. And between 1 and 2, we we have what kind of voltage there. V1 equals the Z1 plus Z3 Z2 over Z1 plus Z3 times V1 this is VA and VB, and VA minus VB equal VO. VO equal this minus VA equal Z2 Z4. Z4 over Z2 plus Z4, Z sub 4 times V1, and this is VO. This VO in series with this RZ, RO, is equivalent to this circuit. Now this is this circuit is the Thevenin equivalent of this circuit is this. And using this procedure, shorting on first step, shorting voltage source, all the voltage sources, and opening all the current sources, idealized sources, to find the output resistance, looking into the output, into the two port, looking into the port, output port, and on second step, we need to find an open voltage or calculate for some insight with, especially with some principle of multiplication or when multiple each when there's several voltage sources and current sources, principle of multiplication says each one of voltage sources and current sources is just one of them is activated and the other voltage is shorted and current is open, or just one current source is activated and the other the other current sources all opened and all the voltage sources shorted cases, and all the sources work around to sum up to the one final voltage is the same as precise calculation, straight calculation of that voltage. The principle of multiplication, multiplication. I forgot just exactly what to say in principle. In Japanese, 重ね合わせ。重ね合わせ. They say 重ね合わせ in Japanese, but principle of 重ね合わせ. There's also the theorem for physics, adding up all potentials makes final voltage like this. Linear combination of the vector or a scalar when without no correlation, no collapsing among these combinations. The principle of something holds, and it's a very important principle for even for quantum mechanics. Principle, but they say principle of not multiplication. But by the way, anyway, on second step, we need to calculate open voltage, and open voltage in series impedance of from first step makes Thevenin equivalence of any circuits. And accurately and deriving Thevenin equivalent in any case is for the start simplest loading cases is looking this. This equals this, but there's no load. This equals this. When this equals this, IL is this. Applying this, this can be folded, but I don't recheck the textbook. I've never rechecked the textbook saying what the textbook saying. Try now. I'm thinking now, and IL is like this, but if this is IO, IL equal IO minus I1, and I0 RS equals VO. So, and I1, this current is IL plus I1, IO. This current looping here is, this voltage is VO, and I call I0 RS, and this current, if shorted, this I0, V0 over RS, and this topology and this topology exchange to this topology, cutting this, excluding here, there's no current IL. Of course, this is the same, this is the same, but adding RL, if RL is infinite, we have IL infinite. We have just V out, and if IL is 0, if this is 0, VO over RS equal IL equals this IO. So IO equal, if this is shorted, of course this IO looped. IO looped in IO loops in this voltage is the same. Now if this is in parallel, this voltage is this voltage IO times RS plus RL equals this voltage. This voltage is must be equal to V1. Must be equal to V1. But IL equals this, and I1 equals not this, because this is opened. This I1 equals, this is IO, and this is this, and V1 equals actually RS plus RL divided by RS plus RL times VO. The voltage divider, voltage divided by RL and RS equals V1. And V1 here, we got what? V1 equal, when V1 equals this, with V1 equals this, I0 IO times R. This is this in parallel resistance. So parallel resistance equal RS RL over RS plus RL. So this is cancelled. This equals this, and this is cancelled. So IO and V1 in IO RS RL, okay, 1 over RL equals RL, VO, RL cancel. So IORS equal VO. IORS equal VO. This holds. So there's no contradiction and no and VO, simply this says IL equal VO over RS plus RL, finite with finite RL loading, and RL is here. The same of this I1 equals the distributed current or ratio of one this current RS over RS plus RL O times IO. So this is IL equal IO minus this. So this minus this is RL over RS plus RL IO. Okay, RS 1 minus this equals this plus RS divided by this. This minus RS equal RL divided by this, and this holds, and this is IL. IL is this, but IO, of course, IO is not VO, so it's IL, current IL equals IS over RS, I1, this minus this, RL, IL equal VO. Oh, this is different. Why? VO. This equivalent circuit is 1. RL. This RL equal VO divided VORS. IORS. IORS equal VO. IORS equal VO. IORS equal VO. VO equal IORS. If V equal IORS, IO in parallel this equals V1. This is V1. V1. This is V1. This is V1. This is V1 because this is V1, and so this is this. This is this. OI equals IORS. IO equal VORS. This is V1. This is V1. IO is distributed in two ways. IL running through capital R square equal RS by RS plus RO of IO. In this case, IO IL equal IO minus I1. I1. Oh, this is not I1. Oh, sorry, I1. I just mistake. I need I1. The I1 is RL, and R, this minus RS, this is RS. So RSIO equals VO. So this is this false. Oh, sorry. So even RL is applied from Thevenin equivalent, we find this IL and this IL is VO over three resistance of IS plus RL, RS and RL. And Thevenin equivalent open circuit consists these conditions. On these conditions, we can exchange left to right, right to left, vice versa. And this is, and finding VO and RS, we need to finding RS shows the VO voltage, so every voltage sources, and looking at from the input output port, and finding all resistance or impedances, and finding VO, we calculate or measure from principles of superposition. now I remember. 重ね合わせの定理 equals from in English principle of superposition. Using principle of superposition, like quantum mechanics, and we calculate the V out, and the V out and the series of source impedance. From that method, we can write Thevenin equivalent of any circuit, any two-port circuit. So and this is equivalent. This is not Thevenin Thevenin equivalent or not equivalent. But this is Thevenin equivalent. When this is Thevenin equivalent of any some circuit, this is said to be not equivalent. This is Thevenin. Thevenin? I don't remember. Maybe this. So try again with yesterday's dummy trial for source followers. This time, delivering Thevenin equivalence. Find an easy way. Using as an easy way to find out the output voltage divided by Vin, which is voltage gain, voltage gain, written as capital V sub V, voltage V equals output voltage divided by input voltage, which has no dimension, and or source follower, simple source follower. This is input N channel, and so back bias exists. Body effect coefficient is what? Gamma not equal 0, and so we have GMB, and G. This is M1 and M2, and this is constant biased current source, and this is the output, input, output. The equivalent from you to write equivalent circuit, Vin applied to this node, and this is gate source voltage of the M1, and this is V out. This is voltage controlled current, and AC VDD equal AC ground, and this is V out, and there GMB V1 exists, but GMB V1 equals GMB V1 GMB VBS body to source. If body to source is positive, body to source positive, body to source positive. This case body equal 0 and positive. This is negative value. Is body to source is inverse and positive, the threshold voltage decreases, and the current is in this direction, and so VBS times GMB equal here, but VBS here equals what voltage? This is bulk minus source, 0 minus V out, 0 minus V out, 0 minus V out. 0 minus V out means, which is V out to 0, and this connect, V out minus 0, this GMB VBS equals just V out. This is just V out minus V out, and the direction is like this, exchange like this, GMB V out. So this is V out and this is GMB. So we exchange current source to 1 over GMB. Because this is the resistance, V out over resistance equals GMB V out, which is the bar control current in right direction with right direction between V out and ground, AC ground. So from this we can find AV with calculating some little calculation, but to utilize this calculation to almost load resistance, when adding load resistance, also for simplicity and utilityness, for utilityness and effectiveness, we need Thevenin equivalent applicable for when it's loading, it's output loading with RL, capital RL. Capital alpha doesn't exist there this time, but we can develop the method to simply calculate that for that cases, and that is the Thevenin equivalent of this. And the Thevenin equivalent, step by step, we exchange these parts excluding 1 over GMB to Thevenin. Thevenin equivalent. Then look, correct. Thevenin spelling, correct spelling of Thevenin. So page 72. Just from yesterday. Thevenin. Okay. This is in French. In French intonation, just as French intonation. Thevenin. I don't know. Thevenin equivalent to Thevenin of how to do. This is ground. This is ground. This is output node, and this is ground. ground to output node. This is from this, looking at this, the M1 ports. This is not. This is DC current and neglected as DC voltage is neglected shorted to the ground, and this is open circuit, and V out, looking at the V out, the contribution of for the resistance is just M1. So M1 looking into source has 1/GM resistance. This is one of the rules of thumb. So we know this. Look. So Z out equals 1/GM. When making the knowledge of this, finding Z out, we remember that Vin is shorted. Every source is shorted, or source voltage is shorted, voltage source is shorted, and current source is open, and find out V0. This is shorted and just 1/GM. This in shorted meaning V in is DC. V in into DC. In shorting V in, it means DC, and it means grounded. DC grounded, but the DC ground, AC ground or DC is on some bias, on some constant bias, and applicable appropriate biased M1 N channel is 1/GM resistance looking into the sources. So being shorted, AC grounded, and biased appropriately having 1/GM resistance looking into the source. Okay. And we utilize this method to find easily from the rules. One of the rules of thumb is important. Rules of thumb. Rules of thumb is difficult to spell. I sometimes mistake rules of thumb, finger, thumb. So difficult to remember. This is not. I hope this is not wrong, but maybe rules on thumb. And next time V out, we need VO. What's VO? And we have GM V1 here. The V1 equals V out minus V in. Of course, of course, V1 equals V in minus V out. And following the rules to find out the Thevenin equivalent, just using KCL or KVL or voltage divider or principles of superpositions. But using principle of superposition, when this is applied and this is opened, are there any voltage there? This is excluding this. Are there any voltage there? Maybe zero. Zero. And only current source exists as neglecting this to be shorted. When shorted, but mm, but V1 is somehow biased, DC biased, shorted in the sense of AC, alternating current. This is non-alternate position and finding out the voltage from this. How to find the voltage means if this is applied, okay, this applied, okay, looking there's no resistance there, so if the resistance 1 over GM here and here, GM V1, and this is AC ground, and this is V out, okay. So looking at the voltage from V out equals looped to making some kind of V1 which is wrong. Also, this is not an equivalence of this, but we take care. This is a point we must take much care to think about how to straight ahead the Thevenin equivalent. Thevenin equivalent is just explained, I've been reading from the book in 3 or 4 minutes, and it's very easy to apply and understand and rechecked again. That in this case, it's abstract topology, and of course, calculation makes the Thevenin equivalence in this book is the same as from the schematic equation from the KVL or KCL, just Ohm's law, but straight to the Thevenin equivalent. How to do it is now still I'm not good at derivation. I'm not good at dealing with this transformation. So it's the theme of today. Even enhancing the understanding and recheck the correctness of Thevenin equivalent and Norton and Thevenin equivalent properties. It's not easy to find out. We know 0, 1 over GM, but VO from 0 to V out. This is V out. I don't know. VO from here. This is V out. Just maybe V out, but this is not V out. Why? What is equivalent part? Excluding area is not this, if I may. Excluding there, this is V out to ground, so we could V out nonsense. Or there's a source being, apparently the voltage is this is this is very simple. It's tricky, but it means just this. And I several months ago I found this is easy, and I've been forgetting my understanding itself. This is the node we taking care of for VO. Okay, from VO. So it's simple. VO equals Vin minus V1. Okay. So okay, VO here equal Vin minus V1, right? Right? VO here, V minus V1, right? It's but V1 in principle or as a from principle superposition, firstly short this. When shorting this, VO equal V1 Vin. When shorting V1 this, and when shorting Vin, what the voltage? When shorting Vin to in the sense of AC ground, V1 also shorted of course Vin equal in this topology VO equals VO. The voltage looking here from this port to the ground is VO, must be VO for Thevenin equivalent, and it's Vin minus V1. But it's not like why Vin minus VO equal VO and 1 over GM. This port connected to this port, this excluded part is the right answer from KCL, KVL, Ohm's law. So the Thevenin equivalent of here is picked up part of this. So looking, this voltage is V out, but open voltage just opened, and this is V out. V out. This is V out. Open V out. This is open V out. And surely the 1 over GM is the RO. So looking at this and this port, Vin minus V1 equals this voltage, so this must be V minus V not Vin, and V minus V1. But V1 is 0, V1 is shorted, V1 is AC, V1 is AC grounded. When V1 is AC grounded, shorted, this is Vin and plus V1 minus V1. V1, this is when this is shorted. This is shorted. This is Vin. This is shorted. This is ground, and this is minus V1. So this is minus V1. This is superposition. I have a doubt, but V1 exists there, but V1 equals V in minus V out. So this is V out. It's weird. V1 equals V1 equals V in minus V out. V in minus V1 because this is V1 and V1 or V1 GM is this current. This current. What kind of Thevenin equivalence there? Here. Oh. So the tricky method. This is tricky. Simply, this is this not this is if this is V or this is V out. This node of course V out, but V out is not exists there from now from this. This topology is these all over topology from these all over topology, and this is defined by the excluded with the excluded part of 1 over GM resistance. So this is not V out defined by all of the topology. So V in there, V1 there, but V out never there. This is just for all of the topology, I think. So this is not exchanged in this time at this time. And also maybe this is not excluded. If this is excluded, there's consistently derived the Thevenin equivalent which is consistent with forward topology, because GMB1 times 1 over GMB is V out, and V in V1 V in minus V1 equals V out, and calculating this, the same result is follows. And so we need to find out some way, VO right here is V in. Why V1 is disappeared from here? From there, disappeared V1 when we just V in, this V in. Am I thinking in too difficultly for these simple cases? GMB1 is there. Norton equivalence. For Norton equivalence, we open Thevenin equivalence to Norton equivalence. Norton straight to Norton. No. One over GM. Why? 1 over G. This and this and this and this is mixtured, wrongly mixtured or not. GMB1, this voltage to this voltage V out to from this to this equal V out. This is not exchanged to 1 1 GM. This is V1. The V1 equal V out to V in. V in minus V out equal V1. What kind of Thevenin equivalent? This is along the by the way, put the Thevenin equivalent concept aside, putting it aside, just thinking about this exact story, or exchange the 1 GM, we can write this is V out, this is V in, and V1 equals V in minus V out, and in between V in and V out, there's a resistance of 1 over GM is this, simply this. But the style is the same as Thevenin equivalent method, but using Thevenin equivalent simply going to the result, maybe because there's independent current sources controlled by separate voltages, abstract separate differential voltages, and in simple manner, there's always for making Thevenin equivalent applicable circuits usually has no no the same. Maybe that's not the difficulty. I think I saw before there's control voltage or current there, and the Thevenin equivalent is correctly applied. The solution is correct at that time, so it's not so special. But from GM V1 we got V minus V out exchange there, and this is 1 over GM V in between V in and V out, and just like this. So in this case we need to exchange, transform from there to here, from there to here, straightly, just watching precisely. On what voltage is applied to make the output resistance. Exchange current to resistance. What the format style is like Thevenin equivalent of these part. And simply these part makes VO equal 1 over GM is okay, but VO or V is a problem. V1 disappears in between this V out. V out over. This is V1. One V1 disappears. Just V. Just V in. Why just V in? Just V in. Just V. Because there's just source of V in. Just V in is there. Because V in there. And V1 shorted. This is open. There's no current. When when this is open, there's no current, which is equal to V1 equals 0. So constant in current, independent current sources, when current makes 0, the control voltage makes 0. It's equal. So looking at the voltage, find VO, we open this, which means V1 shorted equals 0, and V in minus V out equals V out equals V in minus V1, and which is 0 is, so VO equals V in. To think like that is to finally equal to the derivation. So finally leads to the equivalent circuit. So, if there's a current, if there are current sources, we need current sources rejected and equivalently access the controlled voltage. Controlling voltage and independent current sources is open and to find the equivalent voltage sources for Thevenin equivalent. I've never read the document or textbook like about that kind of procedure, but seemingly it's correct in this case. Just leaving this abstract voltage doesn't make correct equivalent circuit, because this is control voltage and arbitral one, and when there's no current of this is opened, this opened equivalent to V1 equals 0, so we need to this V1 0 to get the correct source voltage source for Thevenin equivalent of this part. Maybe that thinking is correct and useful. Current source is when current source is there. Sure. When current source is there, current source is here, voltage here. Current source there, current voltage sources, voltage supply, voltage. Find the looking from the V out, AC using AC equivalent circuit, looking the voltage source looking from the V out node. Because V when current source is opened. Current source is open, this node is V, or current there, its equivalence is just a little bit weird now. Again, still now, I feel uncomfortable for my inspection. Just from inspection, I'd like to find out the inspection to utilize to get Thevenin equivalent of this topology, like written like the one written in this textbook, but the textbook. So just from from here to there, just that. And how, why is never written there. So, but we need to be effective, and we need to get speed to solve the problem, circuit problem, analog circuit problem, using equivalent circuit, or avoiding mistakes, errors in calculation, complex calculations. We need to get insight, how to get insight from the circuit topology, one topology to another, to get simpler one, equivalence assures, which equivalence assures the correctness of and coincidence between calculation and inspection. Such kind of inspection, not method, we need to survive. Speed is a key for any soldiers. Like researchers winning Nobel Prize, they have speed, or so they develop some speeding, accelerating method maybe. Well, they need just 10 to 50 years to winning the prize. But every day, labor market workers, engineering needs solution the day after tomorrow, or tomorrow or the day after tomorrow, or at least in a week, or new development at least less than 5 years. So we need to accelerate using effective way. Usually some insights and rules of thumbs. So one of them, Thevenin equivalent derivation, I like to find out, but I fail again. Maybe this, to find VO, this is opened and this is going to 0, and this voltage this is shorted. This is shorted, this is 0, this voltage appears V out in this equivalent circuit. Well, physically, this is never shorted, so it's weird. Never shorted, and this is not shorted. Now this is V out. Now this is virtual parts, excluding these parts. So that's the second weird insights for just difficulty, or in other words, barrier to block, or barrier to understand. Easy way to barrier to find out the way. Making this Thevenin equivalent to this needs short V1